So, hi friends, welcome back to Code Explorer. Here I am Pavitra Banerjee with you, and you are watching this video as a part of our DSA complete course using Python programming language. And this is going to be our fourth video. And in this video, we will discuss about algorithms. And in our previous video, we have already discussed about uh, we have already revised our Python skills, and then we have learned something about data structures. And in this video we will discuss about algorithms. So here in this website, you know that I have created this website for you guys. Here you can practice, and here you can uh, get all the resources. Here you can get all the study material to learn DSA using Python. So here I have created the fourth page, which is algorithm. So if you click here, you will get this link. You will redirect to this page, and here I have discussed everything. So today we will learn about algorithms. Okay, so basically what is an algorithm? This is our first question. So an algorithm is nothing but it's a step by step instruction set of instruction we have to follow to solve a problem. Okay, so that means algorithm is not only used in our computer science or programming, but we use algorithm everywhere. Okay, let's suppose you are going to take a coffee. So when you are trying to make a coffee, for you, what you have to do at that time, you have to take a bowl first. Then you have to uh, open your gas. You have to then you have to put the bowl on the gas, and then you have to pour the water. You have to mix coffee powder. You have to mix sugar if you want. You have to mix uh, water. These types of things you have to add. That means when you are trying to solve a problem, your problem is that you are sleepy or that types of thing, and you want to take coffee in this time. So you have to take coffee at that time. So this is your problem, and for this, to solve this problem, you are following this particular roadmap. So this is the algorithm for process your problem, to solve your problem. Okay, so this is algorithm. Algorithm is used everywhere in our day-to-day life also. So uh, here I have written an in-depth definition of algorithm. You have to check this. You can get this from here. So now the main thing, that what is the criteria of an algorithm. So the criteria of an algorithm should be, the algorithm should take an input, and then it should give us an output, and the code should be take the input should be finite value, and the output should be definite. Okay, we should a very well output, we want that. So when we will pass the input to an algorithm, it must give us an output, and this should be a finite value. Okay, and for every programming language, the output might be same for a particular input value. That means the algorithm, when we will design an algorithm, that should be an independent uh, to every programming language. That means uh, let's suppose we have, okay, let's suppose I am going to add a new page here. In this page, let's suppose we have an algorithm. So the algorithm is what this is doing, that it is our algorithm, and this algorithm is taking an input. This is taking some inputs, and when we will pass this to an out, when we require our output, at that time, let's suppose when we are using Python programming language for us, the output should be same. When we are using C++, the output should be same. Okay, when we will use Java, at that time the output should same. When we will use JavaScript and every other programming language we will use, the output should be remain same. Okay, that means the output should be, the algorithm should be independent to the programming language. Okay, now here I have given a graph for you, that how can workflow of an, what is a workflow of an algorithm. So the same thing I have defined here, that input, and this goes to the algorithm, and the algorithm processes it, and it gives us an output. Okay, now we have to understand the steps to implement an algorithm. Here I have defined as a beginner to you. I have thought that you are a beginner, you are learning this. If you are an advanced one, then you can also read this, because these are the basically the same for everyone. That first of all you have to understand the problem, then you have to choose an algorithm, you have to break it down, then you have to write the things about the pseudocode, then you have to choose the programming language, then you have to write the code, then you have to test it, then you have to debug it, and then you have to document your code. That means you have to add some comments in your code, that what you are doing, that when if you after sometimes if you when you will forget about that code you have written, that when you will read the comment you can understand that what you have done, and then you have to deploy and maintain it also. Okay, so here are the steps I have defined for you. Okay, now we have to move to our very crucial topics, which is time complexity. Yes, time complexity is the very vital topic to understand algorithms and data structures. Okay, so what is time complexity? Time complexity is nothing but, let's suppose I am showing you something. Ignore the image I have designed. Okay, cut it. Yeah, so here I have written a code of Python that is adding two numbers basically. Okay, you will get the code in the comment in the website also. Okay, so here what is going on, define some array which is taking an argument which is an array, and then we are initializing a variable which is total, that is 0. Then for num in array, okay, then we are increment the number total variable with this num, and then we are returning the total. So what is happening here? So here we have to define the value first, so it is taking an initialization, that is, let's suppose it's going to be our 1. Then we have to iterate all the values. Okay, then it's the, let's suppose there are n values, n elements in our array. Let's suppose in our a double r variable, which is an array, there we have total n elements. So for n element we have to iterate this. So basically then after iterating it, will give us the total value, and it will return us the total. So that means when we will get this, at that time basically it is a linear progression of n. The value, the result of n, will be directly proportional to the size of our n. If n is really very small, then the computation will be very small, and if n is a larger element, n is a very large number, that time n will be the computation will be very huge in number. Okay, so here I have defined all the things. You can check that here I have given a problem that write a Python function to calculate the sum of elements in an array, analyze the time complexity of the function, and calculate its O notation, big O notation. Provide a simple example of demonstrating how the function performs with the different array size. Okay, so here I have given this question, and then I have solved this. So here first of all I have defining a function, initialize the total variable to 0. Okay, here you can see that. Then the second thing we have defined, we are doing that we are using a for loop to iterate through each element in the array, and it then we will add it. That means we are incrementing this value with value of total with this num with the iterating value. Okay, then what we are doing, we are returning the calculated sum. So we are simply returning the total value, total variable. Okay, then how we can basically calculate this time complexity? Here I have written all the steps. The loop in the function runs once for each element in the array. Okay, let's suppose we have n elements in the array. Then as the size of the array increases, the number of iterations in the loop also increases linearly with n. I have already told you. Therefore the time complexity of the function is on, because the running times goes linearly with the input size of n. Okay, here is the funda that you have to understand that what is happening here. Basically time complexity means the when we write a code, at that time CPU has to execute this code. So CPU has to make some calculation to execute the code. So how many calculation, how many computation CPU has to be done is the time complexity of the algorithm. Okay, here I have written the definition also, you can check it. Definition of time complexity, and then what is the definition of big O? Basically, big O is nothing but an asymptomatic notation which shows us the worst case and the best case scenario. Okay, we will discuss about worst case and best case in the next topic, which is base complexity. So here what is going on, I think you have got it, and when you will read this, I think you will be more you will be able to understand more efficiently. Okay, and then we are calculating the big O notation. Here what is the big O notation? Basically, big O when we are calculating a time complexity, at that time I have already I have seen you that this basically proportional, directly proportional to the linearly growth linearly growth of the input size of the n. How many elements we have is directly proportional to that. That means the big O notation will check that the highest power of the variable. So here we have only n value, so the worst case is on. Okay, and then we have the space complexity. So what is space complexity? Basically, space complexity means that how much space required for the algorithm to be executed. Okay, here I have written it in detail uh, definition of this space complexity, but I am telling you the simple definition that space complexity means you have to understand that how many space required for the algorithm to be executed. Okay, so I have given another question here to answer the space complexity. Okay, so write a Python function that takes a list of integers as input and returns the count of unique elements in the list. You are required to solve this problem using additional space, and your implementation should aim for minimal space complexity. Analyze the space complexity of your solution and provide a simple example to demonstrate how the function works. So what we have done, we have defined a function which is count unique elements, and this is taking an argument which is an array, and then we have defined that unique set is basically a set. We will create a set of the array, and then we will return the length of the unique set. Okay, this is a solution, and the solution basically you can see that the space complexity we are analyzing this, the space complexity of the solution primarily depends on the additional space used to store the unique elements. Then in the worst case, basically in the worst case we have to think about the worst case, that means bad or worst. So for worst case, if all elements in the input lists are unique, the set will store all n elements of the list, resulting in a space complexity of on. Okay, the O means the big O. You can read it there. And in the best case, what can happen that we have a set of let's suppose we have a set of uh, duplicate elements, that means 1 1 1 1 1 1 1, that's types of elements. At that time the set will only store the one inside the set, and we the set will return as the this line will return as the unique set. So only one will be there, so the length of the unique set will be only one. So this is our best case scenario. So this is why the space complexity of this code is O1. Okay, here you can see that I have defined something that how this is happening. So here let's we have an array 3 1 4 1 5 9 2 6 5. Here we have 1 for 2 times. Okay, you can see here we have 1 for 2 times. Then in this example, we have total, the list has total 9 elements. Okay, and we one more thing we have that we have this 5 for 2 times also. Okay, so what the when we will pass this array to this code, that means first of all this will create take this array as an argument, then it will create a set for this. That means in set function what happens that when we try to convert a list to a set, the all the duplicate elements eliminated. Okay, so 3 1 4 1 will be eliminated, 5 9 2 6, and the 5 will also be eliminated, so this will print us only 7. So this is the mm, the calculation of O notation here. Okay, so I think you have got a basic understanding of what is time complexity, what is space complexity, and what is an algorithm basically. So I want to give you a quick revision for this lesson. So algorithms are nothing but a step-by-step procedure, step set of instruction we have to follow to solve a particular problem. Okay, here we have written these things. You can read it. Steps of implementing an algorithm, you can read this also. Okay, then we have time complexity. What is time complexity? Time complexity means that the how many times how times to be the code should be the CPU of our system should take to execute the algorithm. This is known as time complexity. And for space complexity, we have that how many space is required to implement the algorithm. Okay, this is the topic for today. And now I want to give you a quick lit code solve. So here we have the first lit code problem, which is two sum. This is one of the basic question of algorithm data structures and algorithms. So how can we do this? Now you have to help me and I will show you that how you can do this. Okay, so first of all, when we have to solve a particular problem, what we have to do, I have written here, you have to read. Okay, understand the problem. So to understand the problem, what we have to do, we have to read the question very carefully. Okay, so read it now. Given an array of integers nums and an integer target, return indices of the two numbers such that they add up to target. You may assume that each input would have exactly one solution and you may not use the same element twice. You can return the answers in any order. Okay, that means now we have to see the test cases. So here we have the input, which is a num, which is the list. Okay, you can say it array also. So here you can see the 2 7 11 15 and our target is here 9. So this is showing us the output of 0 indices 0 and 1. What that means, explanation is here. Because nums 0 means the indexing of 0, that is 2, and the indexing 1 of nums array is 7. And when we will add 2 plus 7, that is gives us 9. So 9 is our target. So we have to define an algorithm to implement this. Okay, so now we can see that how we can solve the problem. So here we have a class solution, and here we have to complete the function, which is toSum, and we have to complete the function. So what can we do? So I want to basically iterate something. I want to iterate all the values of this nums array. Okay, let's see. So what I want to use the for loop here. So for I in range of what, of range of length of nums. Okay, okay, so that means what we are doing here, so we are taking the range of the length of the nums array. Okay, now here I want to create another for loop for j in range of, for which range, let's suppose we have taken this 2. Now we don't want to take this 2 because uh, here you have read that you may assume that each input would have exactly one solution and you may not use the same element twice. Okay, that means 2 plus 2 will be not 9. That's here. That means when we will take an element, we don't need to add this element. Okay, so for that we have to choose our range. So we are choosing our range, that we have to start from I plus 1, and then we have to go to the length of the nums array. Okay, now what we have to check, that if the indexing I and if the indexing j is equal to our target, we have to return our we have to return an array which will be our index. Okay, so let's create an if condition. If nums with indexing I plus nums of indexing j is equal to our target. If this is equal to our target, what we want? We want to return it. We want to return an array include this I and j. Okay, this is our code. So now I want to run this code. Let's check. As you can see that here the accepted runtime, all the test case instance cleared. Okay, so what is happening here? I think you have got it. But now if we want to calculate the time complexity, that how the time complexity is, so basically for this for loop is in for this for loop we have, it's going to the iterating all the elements. That means it's checking all the elements. That means let's suppose here we have n elements. So for that it will take n element as input, and for j it will take, it will exclude this I plus 1, so it has to check n minus 1. Okay, that means we have already n plus n plus n minus 1 we have, and then here we have to check the targeted value. So for every n it have to check, for every I it has to check for the all j, and then it has to check the target. Okay, and all of these are the linear proportional to the length of the nums array. Let's suppose there are n elements, so the watch time complexity of the code will be on. Okay, so this is our uh, uh, solution for this code. Let's submit it. Hmm. We are submitting the code and it's judging the code, the solution. Okay, okay, as you can see that, okay, we can optimize this code. Obviously we can optimize this code, but runtimes, okay, it's for the first problem we have solved together, so it's not a very big deal. And you can see the space complexity has defeated 93.02% users. Okay, that means it's a very big deal. So we have to take confidence from these types of things. We have to take confidence from our own. Okay, and I will strongly recommend you to follow this website. Here we will provide everything you want, everything you need to learn data structures and algorithms using Python. And here I will put the fourth video link, and from here you can play it also, and then I will, and you can read it from here also. Okay, so this will be very helpful for you, I think. And one more thing I want to show you, that the take quiz button I have added it here, but I was unable to upload the quiz here yet, because I will upload it soon. But you know that I am the only person of this code explorer team right now, so I have to make this website, I have to maintain this website also, I have to prepare the notes, and then I have to make the video. So for this reason the frequency of uploading videos has been decreased. But don't worry, I have promised you that I will make you a job ready programmer, who after learning data structures and algorithm you can definitely be a job ready programmer. So stay tuned with me, stay tuned with code explorer. Okay, so that's it for today. I will ask you to practice more and more problems. If you want, you can check all the documentations of data structures, on some documentation of algorithms. You can simply Google it. Okay, so this is for today. I will meet you in the next video. So till then, stay safe, uh, stay motivated, and happy coding. Bye.